Hey, positive, we're down there on our table. We have like almost the 4 components, which are the first one, which is this Arduino Uno, and then you have its USB cable. Then you have the jumper wires, which are male to female, and then you have this, which is a model of the day. And if you take a close look on it, you will find that it is, oh my god, you can see it with the camera, but it's LM75B, which is a digital temperature sensor module. Of course, it is called so because it is based on this chip, which is LM75, and it is a module based on I2C interface. It works with I2C interface. As you see there, you have SDA and SCA, which is a serial data and then serial clock. And among the pin also there we have OS, which is over temperature shutdown pin. And then you have a VCC and the GND, which is a supply. And then the supply of this module ranges between 3.3 and 5 volts. Of course, means that this chip can be a 5 volts logic chip or 5 volts logic module. If you flip it up, you will find that there we have the GND A2 and then VCC, then GND A2 and VCC, GND A0 and VCC. That A2, A1 and then A0 are the combination that allows you to set the address of this module. It means it gives 8 possible address, and among the 8 you can choose one which will be the unique address of this module. See the table here, and you will find that if you take like the combination of A2, A1 and the A0, so that the 2 ground means 20, we will be having address of 48 hexadecimal. So within this video we are going to connect the Arduino and then this sensor, which is LM75B with Arduino, and then we are going to read the temperature in surrounding environment using this module. Okay guys, you see that I finished setting up the circuit, and then you see that the VCC via red wire, it is connected to the 5 volts of Arduino, and then the ground, and then the GND via brown wire is connected to the ground of Arduino, and then the SDA via orange wire is connected to the Arduino analog A4, and then the SCA via yellow wire is connected to Arduino A5. Since I have that circuit connected, I can move on to the code. Okay guys, but before continuing with uploading the code to the Arduino, you have to set the address on which our module will be communicating with Arduino via I2C. For me, I will go with the first choice as shown on that table and set my module to 48 hexadecimal. I will solder A2, A1 and the A0 to ground. Okay guys, now you see that I have the module set to the address of 48 hexadecimal, as I have A2, A1 and A0 soldered to ground. So now we are good to go. Let's jump on computer and see the code, see about the codes and download the codes to the Arduino. Okay guys, here we have our Arduino opened, and then you have the codes right there, and then the code is not too long. You see that it is up to 37 lines, and all those 37 lines are for reading the temperature to this module, means external temperature from LM75, and then display it via Arduino serial monitor, means that icon right there. And of course, you see, as I soldered the I2C address, it was soldered to give 48 hexadecimal as address. So what to do now is to go to the Arduino and then choose the port, which is COM18, and then go ahead and download the code to the Arduino, or just upload the code to the Arduino, and boom, you see that the codes are done uploading. So what's following is to open the serial monitor and start reading the code in our external environment. You see that if you check to the serial monitor, we are having 26.62 degrees Celsius, and to test if our module is responding to the external environment temperature, I'm gonna bring the hot soldering iron, which is this, and then take it in proximity to the sensor, and if you check there to the serial monitor, you will see that the temperature is increasing. This module is suggested to have plus or minus 2 degrees Celsius as accuracy, means the error margin, and then this module can be applied in hobbies where temperature triggering device or where temperature alarm or automatic cooling system is needed. Guys, thank you for watching. I hope that you enjoyed the video. Please give a hand by subscribing on this channel, hit a like, and then give a comment on how this video makes you feel like, and the codes and the circuit are found under description below. If you need a product like this, go under description, and then there you can find either the link to get this module or just the price of it. Ciao, bye.